Hello, good morning, everybody. First of all, thanks for joining our webinar session. I'm Rajesh, MEP product expert from Golden Malaysia. Today, I'm here to share a webinar session with you all, how to overcome MEP and current challenges with MagiCAD. So let me get into today's agenda. So our agenda for today is looking at the overview of the beam, and we're also looking at the advantages of the beam, and we're going to see what are the common challenges of MEP and the current challenges, common current challenges, and the MEP design challenges. And we're also going to see the solutions with the MagiCAD, how MagiCAD is going to help us with this. And we also have a Q&A session at the end of the day. So all our audience, please type your questions in the chat box. We'll try to answer the questions at the end of the session today. So get ready. So let's start with the beam. So I'm not going to share what is beam and all. So, but let me explain a bit brief information on the beam. So building information modeling is a type of workflow that can be implemented by using the different softwares like MagiCAD. So maybe some of you already implementing beam in your works. Today, I will focus on how beam enhance your project by increasing your efficiency, reducing errors, therefore reduce the cost as well. Beam used as a standard in workflows internationally. Sometimes it's easier, harder to implement, but our customer reports that MagiCAD makes it very easy indeed. Beam is undeniably future for us as well. So I hope this will be useful to you. Please don't hesitate to let me know if you have any questions here today. So let's move on to so one question we get asked frequently is, does beam really matters? Though, short answer is yes, absolutely does. Today I'm going to explore this question with you a bit deeper depth through. So the use of beam in your workflow has a significant impact on the multiple aspects, right? So multiple aspects of your project. So I decided to make a quick graph here. You can see here on your screen, a quick graph here to illustrate a couple of points on this topic for you. Here you can see that as the time goes on from the preliminary design, detailed design, construction, documentation, and the construction phase to the operation phase, to the so the ability to impact the cost, you can see the dark blue line is shooting right down. So that when the time goes down, the ability to the cost impact will be going down sharply. So if you compare the same thing with the light blue line, which is the design changes, cost of the design changes. So it's going sharply up as the time progresses. So we can see there. This means that we need to recognize and correct the errors as early as possible in the project in order to avoid it to being too difficult or time consuming and expensive. One way we can manage this by putting a focus on the early design phase. So if we put the focus on the early design phase, one way we can manage this. And what exactly beam workflow does also. So that's what a beam does as well. So now on the graph, we can compare the dark red color with the beam workflow line, and which is most active in the earlier phase, right? And you can also see the light red color line, the drafting and centric workflow, which has a bigger impact during the construction phase. And the beam workflows are much active and much earlier during this time when it is cheaper and easier to implement the changes, right? So we get, whenever before the construction, if you have any design changes, it'll be cheaper and easier to do because we don't need to involve any material there. So if it is during the construction, So we have to involve the people and the material, and it may also obstruct the, it may also slow down the other bodies, other parties process as well. So in a typical BIM workflow, you are connecting with the designing team, analysis team, documentation team, all together in a dynamic environment where all the parties of the project can make changes and can communicate them relatively quickly and cost effectively. So, but how does that impact really matters? So how significant are the savings of the time and money, and how important is the increase in efficiency related to BIM implementation? So one way we can measure the impact is to speak directly to those involved, for example, the contractors. The answers are surprised us not due to the importance of impact of BIM, but due to the philosophy of different advantages of BIM. The benefits of BIM were cited at the top 3 important benefits you can see here. Top 3 important advantages here. So the multiple contractors, and here you can see which they choose. And at the frequency, you can see that strong leader of the course is the reduction in errors and the omissions at 41%. So that's a strong leader, and facilitated with the reduction in errors and omission, collaborating with the others, at 35%, and close behind was the enhanced image to the company at 32%. This means it's also enhanced your company's image. Indeed, the contractors are very aware that implementing BIM also benefit their image, showing that they understand the construction trends and are ready and willing to lead the way to the future. Other benefits cited including the reduction reworks, since the errors are removed earlier in the project. Like we saw, this is a clear benefit for the other stakeholders as well. The costs are reduced, and the contractor has much better control and the prediction of these costs in the beneficial to them. And finally, at joint, we also reduce the duration of the project by 19%. That's a lot, 19%. So when the project duration is reduced, the cost automatically will go down, and as well as we can also venture the new businesses during this time. So these are the results we found from the McGraw Hill construction, the survey. And when we speak to the contractors as well, we found the same results as well. So that's what these are the different in percentage advantages of implementing BIM. So in one way, by implementing the BIM, we can reduce the errors, and we can overcome the challenges. But not just implementing BIM can overcome all the challenges. Sometimes but especially when it is MEP. So we always have a lack of focus on MEP. So most of the industry player look down to the MEP, and then they don't really focus on MEP. Here we have a case study saying that why MEP is so important. So why MEP? Why we need to focus on MEP? This is a hospital case study project. So this is a hospital renovation project done in Finland. So here we took the elements, number of models, number of elements involved in the models. We took each and every piece count, and altogether of architecture and structure is 110K. But when we look at the MEP disciplines, all the disciplines of MEP is more or less a 500,000, or lesser than slightly almost a 500,000, right? So it's 4 times higher than the archi and structure. That's where we need to have a good softwares to implement to handle this all the traits of MEP, and we need to have a good workforce as well. So that's why we emphasize that MEP is also important in terms of implementing BIM. So we don't need to ignore the MEP all the times. So you can also see the number of objects in a meter square. So if you look at the MEP objects, it's more than 12 objects per meter square, where structure and architecture is not even 4 or 2. right? Only the structure elements are two and the architecture is elements are even one. So that's where it shows what is the importance of MEP. And you can see the full life cycle of the beam and what is the position of MEP there, MEP engineers in the life cycle of the beam. And one last thing I would like to specify before we continue to what exactly beam implementation, and when we are talking about the MEP design in particular, there's a lot of misinformation that would be possible to just buy a software, make a 3D model, and suddenly you have a beam. That's not the case. That's exactly why Glodon, we prefer to accompany you along with your BEAM implementation journey. When you use a BEAM software like MagiCAD, for example, you don't just have a 3D model, but you also have all the different elements that make up the project. You have intelligent objects in your design, complete with their geometric dimensions and the data. For example, you have a new process to help you, basically to to exchange the information more easily, efficiently. You can exchange this information with the other parties in the project, like structure engineers or architecture engineers or the fabricators. You can also collaborate with them. So when it comes to the beam, we always need to coordinate, collaborate, and communicate, right? So we can also communicate with other people. So uh, this is not just a 3D model, I mean to say. Okay, so let's move on further. So let's see what is coordinate, communicate, and collaborate. So when you do coordinate, communicate, and collaborate, what will happen? You can see that there's two pictures. One was in the during the design phase. When they design, when they do the coordination, so and they notice that there is a clashes between the pipes are clashing with the other elements. So then they, in the real installation, they bring it down. You can see the real picture installed here. So, and here we have another picture here that's showing the same. What's wrong with this picture is nothing actually wrong here. In the first picture, you can see that the design is already done, and then when they show this to the maintenance people, so the maintenance people actually requested for a ladder to operate the walls. So because the walls are at the high level, so then when it comes to the actual installation, they change the wall position to the down so that they don't need to buy ladder to operate these walls. So that's what happens when you communicate and coordinate and collaborate. But if you don't do CCC, coordinate, communicate, and collaborate, this is what happens. So just make just part of joke. So this is actually a real picture that's happened. And let's move on to our next topic today is what are the common challenges that we are facing with the traditional design and also the beam. So even we implementing the beam, we can suppress some of the challenges, but not all of them can be suppressed. So even if you have you can see first point here, conversion of the drawings from the, most of us using beam softwares like a Revit, and then they just make a 3D model for the coordination, and further down they don't really use that model for the other purposes like converting, extracting the 2D drawings or exchanging the information with facilities management. So these are all the other features are not enjoyed, not really used. So one reason is because we are still in the pioneer stage of using Beam, but now I feel that it's time for us to explore more further down, I think. So and most of them also having issues converting 2D drawings into 3D. So that's where in the traditional practice, we usually do the 2D drawings first and then go into the 3D models. So there are a lot of difficulties doing these conversion issues as well. There are a lot of issues during the conversion, and that takes a longer time as well. And when it comes to the coordination, for the coordination, if you look at the traditional practices during the coordination practices, like a 2D practice, we have to make a lot of sections to do the coordination, and we have to impose the different services, and then we don't really imagine them because there is no 3D. With the 2D, it's pretty difficult to imagine the arrangement of the systems. So that's where we also use Beam. But when it comes to the Revit software or any other software, most of the software don't have inbuilt features to do the coordination. Means we have to engage a third-party software like Navisworks or Fuso or any other software to do the coordination. But the problem is you have to export the entire model into the Navisworks or the third-party software to do the coordination. That also consumes a lot of time because your design was in the different platform and your coordination is in the different platform. So if you have to do immediate changes, it may not be possible immediately. So you have to wait for some time to make the changes. So when it comes to the engineering calculation, so most of our engineers not really using a Beam for doing the engineering calculation, but actually Beam software also allows you to do the engineering calculation. So in looking at the traditional practice, they use a different platform for the design, and they use a different platform for the calculation. So when it when it comes to the design changes, so they have to separately do the design changes, and then they have to separately carry the engineering calculation. That also consumes a lot of time. These are the common challenges that we have commonly, and these are the current challenges. I mean, and one more issue, we always fight for the openings. So when it comes to the openings, we have a different services running around the building, and these are all services are sometimes is smaller, sometimes it's bigger, and especially our projects in Malaysia are quite huge compared with other markets like Europe. So our projects are quite huge, and that costs a lot of, that have a lot of data and a lot of crossings in terms of openings. So to handle this provision for voids, all this while we were using the RFIs, right? So we used to rise an RFI, and then we get the RFIs. We keep sending the RFIs, and then at one stage we also don't have a track record of which RFI is approved or which RFI is not approved. And we also have a pipe sleeve. Some areas like we have a crossing the beams and all. So we also need to put the pipe sleeves. All these things in the traditional practices were a bit difficult. Even if you have using any other beam workflow, it's also been carried with as a heavy work, and the person especially assigned just to carry these provisions for building works, which can be done in a faster way. So later I'm going to share with you guys, now I'm going to share with you guys how we're going to overcome all these problems. Converting the models into the drawings. So when you use a MagiCAD, yeah, MagiCAD will do the device arrangement automatically based on the room area. So you don't need to separately go and pick and install every single device. If you pick a room, the MagiCAD will help you to, MagiCAD functions will help you to install the devices automatically. And when it comes to the conversion, the 3D model, when you want to convert into 2D symbol, you need to have a 2D symbols, but most of the people Revit families don't contain the 2D symbols, and you might need to change these 2D symbols frequently. But in MagiCAD, we already overcome this issue with using a 2D symbol. In every 3D model of MagiCAD, this comes along with a 2D symbol. So these 2D symbols can be adjusted, can be changed at any time during the project. And not just that, we can also do the automatic tagging, automatic numbering, and we can also do the automatic sizing. So here we can see a simple sample here, how we're going to place the devices. For example, here I took at this room, and how I'm going to install the sprinkler devices, how I'm going to connect the pipes, and how I'm going to do the sizing for the sprinkler network. So let's go. So first thing, as I mentioned, every 3D model in the MagiCAD comes with 2D symbol. So user can select the 2D symbol at any time. And then they can also access the international symbols, not just local symbols. You can also access to the, if you have a projects in the overseas, you can also access their international standard, international symbols belongs to that country. And then we go arrange the devices by using an array, and you can also select by space, by room, and after that you just need to specify the distance. For example, like here in 3 by 3, so now the software will automatically arrange the devices automatically. You don't need to go and place each and every single device. This is applicable for all the devices like lighting fixtures or sprinkler devices or aircon grills or anything. So you can apply these product installation options are available for every single discipline. And then we go and draw a pipe here. So we don't need to draw every single pipe, especially when it comes to the sprinklers. We have a lot of pipes, right? So then we don't need to draw all the pipes. And then once you draw a main pipe, you can apply the connection tools. We have a sprinkler connection tools, and we also have a drainage connection tool. We also have a device connection for the ACMB. We have a plumbing. Every discipline has their own connection tools, basically. And then once you choose the connection types, then you can click finish, and then you can select target the pipe where you want to connect. Then you can see that you can also adjust the range pipe and also the sprinkler pipes, and you can also connect the rest of the sprinklers which is not connected. And then once you're done with the connections, now we are going to resize this network according to the sprinkler tables, right? So the sprinkler tables are pretty easy to understand. So you just need to key in this how many sprinklers of each area, 3 sprinkler 25 or 4 sprinkler 32, or you can also follow the NFPA or MS standards tables, and then you can apply the sizing. So once you click the sizing and then just update to the model, then it will automatically resize your entire network for you. You don't need to go and do every single size, I mean to say. So then you can further move on to the engineering calculations. That part we're going to see later. And here we can see another device connections here. So for example, if you have aircon devices, how are you going to connect the aircon devices? For example, you just select the device and then select the pipe, select the main duct, and not just connecting, you can also choose a tap connection or T connection. These are the standard fittings that we available, that we usually use. And not just standard fittings, we can also assign the flexible duct. Most of the aircon grills are connected with a flexible duct at the end. So then you can also assign the flexible duct length. For example, 1 meter or 2 meter or 500 mm, you can assign the flexible duct length, and you can also choose the angle if there is an elevation difference. Then once you apply, then you can click OK, then the connection is done in the model. So you don't need to go and connect every single device. That boosts up your process. We call it, these are the productivity tools, I can say. So these productivity tools help you to boost your production time. I mean to say, you can save a lot of time during the modeling, and you can spare a lot of time for the coordination, or you can spend a lot of time for the other works. So here you can see the connection is done at both sides. Once you have a flexible duct, you can move that the device at anywhere you wish. So these are the productivity tools. And when it comes to the coordination, as I mentioned, we always use a third-party software to do the coordination. But for the first time, we also bring the coordination, whatever we do in the other softwares like Navisworks, we also bring it inside the Revit. So now you can also do the coordination inside the Revit software, as MagiCAD is a plugin for Revit and AutoCAD, so you can also do the coordination inside the Revit. So not just doing a coordination, because this coordination is already everybody is doing. What is the specialty of MagiCAD here is we can also do the real-time clash detection. So especially during this period, like MCO, movement control order, is in place. So we sit at the home, and we can also do the real-time clash reduction by using MagiCAD. So this will really help you during this, especially during the MCO stage. You don't need to export your models, or you don't need to share your files with others. So you can actually do coordination within your Revit software. So here we go and see what is the real-time clash detection. First, you can see when I on the real-time clash detection, when I start drawing a different elements, for example, if I draw the pipe, so the software will automatically detect the clashes immediately. So it means I don't need to wait for the software to run the clash check separately. So where I can directly detect the clashes by using the real-time clash detection. So not just a hard clash, this is directly clashing, and you can also detect the soft clashes. So you can see the soft clashes are defined in the different colors. So you can also change the colors, of course. And even that's not only that, if you draw pipes or very close to the wall or anywhere, it will also still able to detect the clashes, where you can see that sometimes it may be acceptable, sometimes it may not be acceptable. So you don't need to run into a software to cross check these clashes. You can using your current design software, and then you can do the clash checking. And first thing first you need to do is you need to on your clash settings, And other than that, you can also choose a discipline, which discipline against which discipline. This one is pretty similar with Navisworks, I believe. And you can also define the colors, what color you want to use for the hot clash, what color you want to use for the soft clash, and what are the clearances, tolerances. That means to identify the soft clashes. You can also ignore the openings as a clashes. If you create openings or anything, you can also ignore them as a clash. Then we go for the clash checking. So this clash checking will help you to identify all the clashes that are available in the model, and these clash report can be exported into the Excel. So you can we also have an export option, and you can also retake the photos. For example, if the pictures are not sufficient taken by the software, you can also retake a new photo, and you can also directly edit them in the Paint, where you can comment or you can type your comments very easily. And these are the works in other softwares. You have to take a separate tool like a screenshot. You have to take a separate screenshot, and then you have to add this screenshot into a report again. But in MagiCAD, you no need to do that. By sitting at home or sitting at the office, you can actually looking at them inside the model. You can recheck the photos, and then you can directly attach them into your report. So that report directly will generate into Excel. From there, you can share your report with other parties who are involved in these clashes. So let's move on to the next. So when it comes to the engineering calculations, MagiCAD supports a lot of engineering calculation with the local and international standards. So let's say what are the calculations that we can do is duct sizing, balancing, pressure drop calculations, and the sound calculation and the space sound calculation. These four are for the ACMB systems. And when it comes to the piping, we can do the heating and cooling, sizing and balancing, domestic water sizing and balancing, and the sprinkler sizing and sprinkler calculations. So if you look at the other softwares like Revit, doing a sprinkler calculation is far away. So they may not be able to do the sprinkler calculation for you. But in MagiCAD, you can also do the sprinkler calculation by using the different standards like NFPA, British standards, or European rules. And we also implemented the Malaysian standards and the Singapore standards when we launched into the local areas. And not only that, sprinkler calculation, we can also do the electrical calculation. For the electrical calculation, we collaborated with Schneider Electrical, and we are using the Schneider Electrical calculation engine and the IEC standards. So we can do the power loads, cable sizing, voltage drop, and the short circuit calculations in the electrical. So here we're going to see how we're going to do the sprinkler calculations here. So all you need to do is we just need to define your sprinkler design area and the hazard classes. And once you're done with this, you just specify what are the worst case sprinklers. For example, I took these 9 sprinklers in the worst case scenario. Then I go for the sprinkler calculations. So here I'm going to select my design area using the NFPA standards, and you can also choose a method whether you want to use a Hazen-Williams or Darcy. And if you're not connected with the pump, it will also help you to calculate the required pump capacity. If you're connected to the pump, it will help you to balance to the pump pressure. So we work vice versa. And you can also have an option to control your velocity, like 10 meters per second is a maximum velocity. If you don't want to exceed, it won't stop you by exceeding the velocity, but it will produce an error if this exceeds the velocity, right? And then once you're done, you just click OK, and then you can see that. And from the report, you will understand what is the required pressure at the feed point, and what is the flow, and what are the number of weakest sprinklers, and all the other sprinkler results and the system results, where you can see the node numbers is also automatically generated in the. So where you need to separately go and draw the isometric diagrams, especially engineers, they have to draw the isometric diagrams in terms of to verify the calculations, right? So you don't need to draw the separate isometric diagrams. You can directly generate the isometric diagram with the node numbers. So all you need to do is you just update this information to the model, and then the node numbers will be transferred to your data. So if you have any changes, you just click recalculate. If you have any changes in the pressure, you just click recalculate. It will automatically recalculate for you. You don't need to redo the same thing from the scratch. And the same thing we can also see at the ACMV systems. So when you want to do the balancing or pressure drop calculations, you can see the network is already sized, and we can also balance to the minimum pressure, which is will estimate the required fan pressure for you. And you can also see the total flow and the total pressure and the pressure drop area, pressure drop values at the each and every. And you can also see the index route, which is a critical part in this network. And all this will also generate the node numbers like sprinklers, and this also help you to generate the isometric diagrams for your cross verification or the authority submissions. So all you need to do is you can also print these reports and then put up in the title block, and then you can submit to your authorities directly. Right. So these are some examples of the engineering calculations. So this will save your time by 100%. I mean, you can save a lot of time in terms of design as well, not just modeling. You can also save time in the designing. So, and one more thing for one of the most common challenge is provision for the openings. So openings is always been a big issue. So we have to, we used to write, when I was working there as a, working for the contractor, we used to write a lot of openings. And end of the day, we have no track record of which RFI is approved or which RFI is not approved. And then we ended up fighting each other with and we also sometimes, if sometimes it may not, the RT or structure engineers may not allow us to do the openings at that particular wall. It may damage the aesthetics of the wall, or it may damage the integrity of the wall. So that's where in MagiCAD we come up with a solution and saying that how we can manage these openings in one single platform. So since we have done everything in the 3D, why not we use this 3D model to create the openings as well? But same like RFI, we're going to write this information to the archi and structure engineers where they can go through all the openings and they accept or reject these openings directly. So all you need to do here to do the openings is you can set up your opening sizes. So based on the sizes or pipe ranges, or maybe it can be vice versa, you can use a standard opening size like this, or you can also follow the pipe sizes like a 25 diameter 50 opening, or 50 diameter opening 100 mm. So like that also you can do openings. And you can also display the discipline names like ventilation B, piping is HP, a sprinkler is a sprinkler S is a sprinkler. So you can also define so that the RT and structure engineers understand that this opening is belongs to which discipline. So then once you're done with that, we go for an automatic opening. So these automatic openings help you to create the openings by current view or by flow or by selected objects. So we have no restrictions on this. You can do it like you wish. Then now I'm going with the current view. So then now all my openings are processed. So here in the add-ins, we have a void plugin, which is free for the RT and structure engineers. Those who bought our MagiCAD software, they can also share these void openings with other players like structure and RT engineers for free of cost. So they can read all the openings by using this void. So let's see how does it look like. So then here you can see the ID of it and who's the owner, what level it is, what is the status, what is the comment, what is the size, what are the coordinates. So these are the list of the openings that we have created, right? So you can also go through each and every single opening that will show in the 3D. So once you're done with the MEP part, so as a MEP engineers, we can only request the openings. We have no right to create openings directly, right? So we send this file. We're going to send this file with RT and the structure engineer. We're going to share this. Once the RT and structure receive the model, they link the MEP files first. And once they link the MEP file, they're going to check the openings by using this free plugin. So when they click at the void, they will list down all the openings are created by the MEP engineers, and they have a status column. They can also cross-check by using this view, and then once they check, and they can accept or they put a status or accepted or reject. By using this report, we can communicate each other. If this is not acceptable, so they can also reject, and every rejection there must be a reason behind the rejection. So they can also put the comments of the rejection, reason for the rejection. And once they're done, they can also create a void by selecting the elements. So selecting particular openings, they can create a void. Then this opening will fully reflect. Now the opening is fully open. Now you can see that opening is fully created. Now we can also see this in the wall 3D. So not just opening, this will also help you to detect the quantities in terms of wall opening. So if the opening is too big, you might need to estimate the quantities. The QS might need to avoid this opening volume as well. So they can also take this into the account for the wall openings. So that's also that also makes a lot of difference in the quantities. Right. So this can be done within your Revit. You don't need to separately use different methods to do the voids. So, and you can do all the openings at one shot. You don't need to separately do them each and every one. And especially we have seen people are assigning assigning the people just to manage these works. But these works can be done in few minutes. You don't need to spend hours and hours or days and days on this. So that ends my presentation for today. And if you have any questions, please do ask in the chat box. I will try to answer them as soon as possible. So far, I don't see any questions. Yeah, I request audience to type all your questions. Afik Hashmi raised the hand. Yeah, Afik, you can ask your question in the chat box. We'll try to answer your questions as soon immediately. Any questions? So I believe you understand my presentation, if no questions. Is that? Okay. Yeah, I got a hello Rajesh. This MagiCAD can produce a schematic diagram. Yes, we can also we can draw the schematics, but in terms of electrical, we can produce the schematic diagrams. But in terms of a normal schematic, like a single line diagrams for the single line diagrams for the mechanical systems, we have to draw we have a separate discipline called a schematics module. By using that schematics module, you can draw the schematics within the Revit environment, and you can exchange the information from the model to the schematics, but we don't really generate the schematics except the switchboard schematics. Yeah, switchboard schematics we generate, yes. But other single line diagrams, no, we have to draw this we have to draw the single line diagrams, and then we have to link with the model again. Afik asked a question. Hello, Rajesh. MagiCAD can produce a schematic diagram. Yes. Simple question. I don't see the question here. Afik, I don't see your question on the. Is there a? You can type your question. Is it yearly subscription, and how much will it cost? Yeah, Saiful, good questions. We can answer this in a separate session. We do have a subscription and the permanent licenses at a reasonable prices, and I can say it's not so expensive with the reasonable prices. And we can please we will contact you in your email, so saying that we can share the price information with you. Any other questions? Yeah, how much price is this plugin, MagiCAD plugin? Yes, so it's at a reasonable price we are selling this. So we can let you know by directly. So this is not, I'm not we're not showing in the public. So hope you understand that. Yeah, thanks. We also looking forward to hear from you. Any other questions? Yeah, if no questions, we will I'll call it a day. And thanks for joining us. Keep in touch with us. We will get back to you shortly. And thanks for watching us. And today we're gonna give you a handout as well, which is white papers, which is released by our MagiCAD team, and how to on the beam white papers, two white papers, and beam adoption in Europe, and one more thing is, yeah, how you implement, what is the lifetime cost of what is your on top of the beam white, both white papers are on top of the beam. So we will email to you that as well. So the white papers will be emailed, distributed to the emails. So one last question, anybody? If you have any questions, please raise. Yeah, thanks. Thanks. Signing off. Bye.